Hey everyone, these are the proportions and real-world percents guided notes. So let's get started on talking about proportions. Two equivalent ratios or a proportion are useful when solving real-world percent problems. So a proportion is just another way to say two equivalent ratios. Proportions can be solved by using a multiplicative factor. The multiplicative factor can be either horizontal or vertical. Actually, there is a multiplicative factor, both horizontal and vertical. You don't need to use both. One may be more obvious than another. Let's look at the proportions below. So if we look at this proportion right here, 4/12 equals 7 over n. And this proportion, the factor between the numerator and the denominator is, so if I notice right here, I can multiply 4 by 3 to get 12. There is a factor horizontal, although it may not be as obvious. To determine the value of n, I'm going to multiply 7 by 3 as well, and then I get n equals 21. Let's look at the next one. 11 over 5 equals y over 10. In this proportion, the factor between the denominators is, so now it may be more obvious that going horizontal, I multiply by 2. To determine the value of n, multiply 11 by 2, and I get y equals 22. So again, there will be horizontal and vertical. One way just may be more clear than the other. Look at this practice. Determine the value of the unknown. So looking at this first one right here, I know it's horizontal. 2 times 5 equals 10. So going this way, some number times 5 equals 15. And then I know that it has to be 3. 3 times 5 equals 15. If I don't know, I can think of it as division. 10 divided by 5 is 2, and then 15 divided by 5 is 3. Looking at this one right here, I notice that horizontally is multiplied by 4. I may also notice that going this direction, vertically, it's multiplied by 2. I can do either one, and it's going to give me the same answer. So some number times 4 equals 4. That must mean the sum number is 1. And that going vertically, that number times 2 is 2. So I don't need to do it both ways, but I can. So y equals 2. Looking at the next question right here, 3/10 equals 30 over a. I notice horizontally that 3 times 10 is 30. So 10 times 10 equals a. And that must mean that a equals 100. Last one. 9 over 18 equals b over 24. I notice that vertically I multiply by 2. 9 times 2 is 18. So some number times 2 is 24. And I know that some number is 12. Again, you can divide if you don't know. 24 divided by 2 is 12. So b equals 12. While there will always exist a multiplicative factor, sometimes you may prefer to use a different method. Let's look at the horizontal multiplicative factor in the proportion below. So going horizontally on this proportion right here, 9 times some number equals 4. I don't know clear what 9 times what equals 4, but I know that if I multiply by this reciprocal here, so it's 4/9, that those 9s will cancel out and then I'll get 4. So if I multiply the top by 4/9 as well, I get, hold on, so 9 times 4/9 equals 4, then 2 times 4/9 multiplying across will give me 8/9. Instead of using the multiplicative factor, we can use our knowledge of solving equations. So I can do it this way, but I can also look at it as solving equations. To solve an equation, the variable needs to be isolated. That means it needs to be alone on one side of the equal sign. In this case, multiplying each side by 4 will isolate the variable. So let's go back to this right here. So I want this n right here to be all by itself. So I need to get rid of this 4. So if I multiply each side by 4, these will cancel out, and I get 4 times 2/9 equals n. That's what I'm showing down here. Multiplied each side by 4, and then that will give me 8/9 equals n, because 4 times 2 is 8, and then divided by 9. Look at the proportion below and let's solve for the variable. To isolate the variable, you will need to multiply each side by, so looking at this right here, I want my x to be by itself. So I need to get rid of the dividing by 6. So I'm going to multiply each side by 6. And then it will say x equals 1 times 6 divided by 1.5. All right, so what did I do? I multiplied each side by 6. Show this on the proportion below, which we did. Recall, to simplify completely, you can divide by that denominator. So it's saying I need to divide by 1.5, so 6 divided by 1.5, I get x equals 4. Solve the proportion by isolating the variable. So I want my x to be alone, so I need to get rid of the 4. So I'm going to multiply each side by 4, and these are going to cancel out and give me 1, so 1x. I need to multiply this side by 4 as well to keep the equation balanced. Then I have 2 times 4, which is 8, and then I need to divide that by 5. So 8 divided by 5 gives me 1.6. Now we will look at a proportion when the variable is in the denominator. So the ones we just did, the variable was in the numerator. But what if the variable is in the denominator? One strategy is to flip both of the ratios. This will not affect the proportion because the horizontal and vertical factors will remain constant. So looking at this proportion right here, I have 2/9 equals 5 over n. I'm going to flip it. So I'm flipping my first one, so I get 9 over 2 instead of 2 over 9, and I flip my second one. So instead of 5 over n, I have n over 5. Now I can do the same thing. Solve for the variable by multiplying each side by, well, I want my n to be alone, and it's n divided by 5, so if I multiply each side by 5, that will cancel out and give me 1n, but I need to multiply this side by 5 as well. So I'm multiplying each side by 5, then I have 5 times 9, which is 45, divided by 2, and that will give me 22.5. Look at this one. Solve this proportion right here. Flip the proportions first to have the variable in the numerator. All right, and so instead of 3 over x, I'm going to write x over 3. And instead of 4 of 11, I'm going to write 11 over 4. Now I need my variable to be by itself. Right now it's divided by 3, so if I times it by 3, that will give me 1x times this side by 3, okay? So solve for the variable by multiplying each side by 3, and then I have 11 times 3 divided by 4, and that's going to give me 8.25. All right, let's do this proportion right here. It says 2/3 equals y over 8. Again, I don't notice any obvious multiplicative factors, so I'm just going to solve it by isolating my variable, which is y. It is already in the numerator, so I don't need to flip it. Since it's y divided by 8, I'm going to multiply each side by 8, and that's going to give me 1y. Multiply this side by 8, so I have 16 because 8 times 2 is 16 divided by 3. It tells me to round to the nearest tenth, so that's going to be about 5.3. Next proportion, n over 5 equals 3/2. Again, my variable is already in the numerator. I don't notice any quick multiplicative factors. They are there, but I'm just going to do it by isolating my variable. I'm going to multiply each side by 5 because this will give me 1n. Multiply this side by 5, so I have 3 times 5, which is 15. Divided by 2, I get n equals 7.5, 7.5. Down to the bottom, 2.5 over 6 equals 8 over x. Again, I don't know any quick multiplicative factors. I'm going to flip this because my numerator right here is in the denominator. So I'm going to flip both ratios. So I have 6 over 2.5 equals x over 8. Now my variable is in the numerator. I can multiply each side by 8. That cancels out and gives me 1x. Now I have 6 times 8, which is 48, divided by 2.5. I get x equals 19.2. Last question on this page, 0.5 over m equals 7 over 6. I am going to flip my ratios here because my variable is in the denominator. So rewriting these, I have m over 0.5 equals 6/7. Now my variable is in the numerator. I can multiply each side by 5/10, and that gives me 1m over on the left side. Multiply this side by 5/10 as well. 6 times 5/10 or a half divided by 7, and rounding that to the nearest tenth is going to give me about 0.4. Now we will apply proportions to real-world situations. Recall that when setting up proportions or equivalent ratios, there needs to be a connection both horizontally and vertically. Let's do a quick review of writing percents as ratios. 15% as a ratio. So remember, percent means per 100. So 15% would be 15 hundredths. 120% as a ratio is 120 out of 100. 2.5% as a ratio is going to be 2.5/100. Let's set up a proportion for the following scenario. Your hamburger and drink you purchased for lunch total $4.50. I'm going to underline that here. There is a 3% sales tax for food purchases. Find the proportion below to determine the amount of sales tax. So look at my proportion. It's already started for us a little bit here. I have my parts on the numerator, my wholes on the denominator, my food on the left, my percents on the right. So my whole food is going to cost me $4.50, and that is coming from right here. Now my part percent, which it tells me right here, 3%, is coming from right there. So that's going to be 3 in my numerator here on the right. So solve this proportion by multiplying each side by, so I have my variable here in the numerator here on the left. And so I'm going to multiply each side by 4.5. And that's going to let me solve this. So that's going to cancel out. So x equals 3 times 4.5 divided by 100. And that's going to give me 0.135. All right. So I had to pay about, and I'm going to round that because when I pay with money, it's cents. So the nearest hundred. So that's about 14 cents tax. How much total did you spend on lunch? Well, it cost $4.50 without the tax, plus the tax, and that's going to give me $4.64. Sally's shoes that she wants to purchase are $50. Let's mark that. That seems like important information. The store is having a sale tomorrow. Everything is 15% off. That also seems like it's important information. We'll mark that. Complete the proportion below to determine how much Sally will save if she purchases the shoes on sale. So it already has my shoes here on the left. So my part shoes is what I'm trying to figure out. My whole shoes means what they cost when they're not on sale. Has my percents here on the side. On the right, it has my whole percent. And then it tells me that it's 15% off. So that's going to go in the numerator here on the right-hand side. Solve this proportion by multiplying each side by, well, if we look, my variable is already in the numerator, so I just need to multiply each side by 50. That will cancel that side out. Then I have 15 times 50 divided by 100. Okay, so solve this proportion by multiplying each side by 50. 15 times 50 divided by 100 is 7.5. So Sally would save $7.50 by purchasing them on sale. How much do the shoes cost on sale? Well, they are regularly $50 minus $7.50. That means they are $42.50. The bookstore raised all their prices by 20%. I'm going to mark that 20%. It seems like it's important. A book cost $15. Again, important information. How much did the book cost after the prices were raised? You first need to determine 20%, right, of $15. Because if I can figure out 20% of $15, that's going to let me know how much they raised their prices as. So let's do that using a proportion. So if you look over here, these are going to be my percents here on the side. And this is going to be the cost of the book. So it's telling me that the cost is 15. That's what it is without the sale. And then my percent is going to be 20%. So I have my 20% over here, part to whole, and then my cost part to whole there. My variable is already in the numerator right there. So if I multiply each side by 15, then I can figure this out because these will cancel out. So solve for the variable by multiplying each side by 15. Then I have 20 times 15 divided by 100, and that is going to be 3. The price of the book after raising the price is, well, it was $15 plus $3, so that gives me $18. And then it asked me how I determined this, and I added the increase to the original price. It says John is a realtor, and he receives 3% commission of all his sales. He sold a $300,000 home. Finish writing the proportion below to determine how much commission he received. Okay, so again on my right hand, it already has it set up that this is going to be my percent. And then here on the left side is going to be my price or my cost here, my dollars amount. All right, so my percent, let's write my percent. It's going to be 3% here, part to whole. And then my whole, for my left side, my whole is $300,000. That's how much the whole cost of the house was. I don't get that much for commission, but that's how much the cost of the house was. So I got my proportion set up, and then it's asking me, it says solve for the variable by multiplying each side by, well, if you look, my variable here is already in the numerator. So if I multiply each side by 300,000, that'll cancel and give me 1x. Multiply this side by 300,000. So I multiplied each side by 300,000, and then 3 times 300,000 divided by 100 is going to give me 9,000. So John received $9,000 in commission. It says your family went out to dinner at a local restaurant and spent $52. Again, important information. Let's mark that. You had great service from the waitress, and you wanted to leave a 30% tip. Important information. Let's mark that. Write a proportion to determine the amount of tip to leave. Okay, so let's write my percent here on the side like I've done before. So my percent is 30%, so part to whole, 30 over 100. And I spent $52. That's my whole here on the left. That's my money. But I want to figure out how much tip do we leave. So that's my unknown. That's my part. That's my whole. Again, my variable is already in the numerator, so I just need to multiply each side by 52, and that will help me figure out what my x is. So 30 times 52 divided by 100 is going to be 15.60. So that would be a 30% tip, would be $15.60. What would the total cost for your family to eat dinner at the restaurant? Well, it cost me $52 plus the tip, which was $15.60. My total cost would be $67.60. Okay, doing this one, it says Sam left a 20% tip. Let's mark that information on his lunch bill of $16. How much total did he spend? So let's write my proportion. I'm going to keep my percents here in the right. Now I don't have to keep the percents in the right. It doesn't really matter as long as I'm consistent with how I set it up. But we'll do 20 over 100, part to whole, and my money here in the left. So my part, I don't know. That's what I'm trying to figure out. And then $16, part to whole. Okay, my numerator here, my variable is in the numerator, so I'm going to multiply each side by 16. Those will cancel out. So 20 times 16 divided by 100. That tells me that x equals $3.20. Now the question says how much total did he spend on lunch? So that's going to be the amount he spent plus the tip. So 16 plus 320 is going to give me $19.20. All right, it says all books were marked 25% off their original price. So mark 25%. And a book had an original price of $22. what was the sell price. So I have my percents here, which I'm going to write part to whole, 25 to 100, and my money here on the left, my whole is 100. I'm trying to figure out the part, which would give me how much I'm taking off for the sale. And so my variable is already in the numerator here. So I'm going to multiply each side by 22 to isolate that. So 25 times 22 divided by 100, and that tells me x equals 5.5. So it says, what was the sell price? I need to take the original price and minus 5.5, and that's going to give me $16.50. All right, this next question says, determine the total cost of headphones that cost $50. Let's mark that, it's important, with 6% sales tax. Okay, let's write this. So my percents here on the right, so 6% is 6 out of 100. And then I'll do my money here on the left. Again, I could switch these as long as I'm consistent with my proportion within the problem. But my whole is 50. I'm trying to figure out the tax. So that's going to be my part. That's going to be 6% of 50. So that's going to be my part in my ratio. And then solving this, my variable's in the numerator. So I need to multiply each side by 50. That gives me 1x. So 6 times 50 divided by 100. That lets me know that x equals 3. So the total cost, I'm going to be adding it since it's a tax. So 50 plus 3 is going to give me $53. Let's look at this question. Rachel had to give 15% commission, let's mark that, on her sales to the company she worked for, and she could keep the rest. In one day, she sold $130. How much of her sales could she keep? Okay, let's do my percent. So it's 15%, 15 to 100. And my money here, my whole is $130. And my percent of 15 is going to be what I'm trying to figure out, my commission. So again, my variable is already in the numerator. So I'm going to multiply each side by 130. I get 15 times 130 divided by 100. So I get x equals $19.50. So in one day she sold $130, and how much of her sales could she keep? So she's going to be subtracting that. 130 minus the money she has to give to the company, and that's going to equal $110.50. All right, now we're going to be talking about percent change, all right? It says, let's use proportions to determine percent change. The local grocery store changed the price of a large box of cereal from $5 to $4.50. That seems like that's important. Let's mark that. So from $5 to $4.50. We want to determine by what percent the price changed. Determine the difference in the amount. So we need to figure out the difference of the amount first. So it went from $5 to $4.50. So the difference is going to be 50 cents. And I figured that out by subtracting 5 minus $4.50. And that gives me 50 cents. Keep this amount positive. We will use the amount of change with our proportion. We want to know percent change from the original amount. Therefore, we will use the original amount in the proportion. Okay, so we're figuring out by what percent did it change by. So the change has to be in the proportion, all right? So my change is 50 cents, or 0.50. Solve for the variable by multiplying each side by, okay, my variable is already in the numerator, so I need to multiply each side by 100 to get it by itself. So 100 times 0.5 divided by 5 is going to give me 10. So the price of cereal decreased by 10%. Your dog weighed 20 pounds when you first received him. Now he weighs 50 pounds. Let's determine by what percent did his weight change. So percent change. First, we need to determine how much did the dog change by. So he went from 20 to 50 pounds. So the change is 30 pounds. Now let's set up our proportion. Remember, you want to know the percent change from the original amount. Our original amount is 20 pounds. That's our original. And then it changed by 30 pounds. And I'm trying to figure out the percent here, which is my variable, which is in the numerator. So I'm going to multiply each side by 100. So 100 times 30 divided by 20 is going to give me 150. The dog's weight increased 150%. Juan bought a house for $400,000. 5 years later, he sold the house for $480,000. To determine the percent change of the value of the home, we need to determine how much the price changed by, because we're figuring out percent changed. Keep this number positive. Okay, so it went from 400,000 to 480,000. So that's going to be a change of $80,000. If I don't know that, I can always subtract. I just want to keep the number positive. So my original price here is going to go in the denominator, and how much it changed by is going in my numerator. So the original price was $400,000 and it changed by $80,000. Okay, I'm figuring out percent change. So my variable here is already in the numerator. So I'm going to multiply each side by 100. That will cancel. So 80,000 times 100 divided by 400,000 is going to give me 20. I multiplied each side by 100. Okay. So the home, did it go up or down? The home increased in value by 20%. Shawnee bought a home for $500,000. Let's mark that information. 5 years later, she sold the house for $460,000. Complete the proportion to determine the percent change in the value of home. All right, so I'm going to write my percent here. I'm trying to figure out by what percent change that is. So it's X over 100. The original cost of the home was $500,000 and it changed from, so it went from $500,000 to $460. Keeping the number positive, that is $40,000. That's a change by. So I'm going to solve for the variable by multiplying each side by 100. So I have 40,000 times 100 divided by 500,000 is going to give me 8. Now I wrote X and they wrote N, so that's okay. I can change this to an N. The home did increase or decrease in value. So the home decreased in value by 8%. Here is a summary. If you want to mark this in your notes, here's a summary of percent change. Percent change is the difference, or how much it changed by, over the original amount, and then your variable over 100. Now we're going to look at percent error, which is similar, but it is different. Percent error is a measure of how off an experimental or estimated value is from the actual value. Okay, so Diego estimated that 75 people came to his party, but 90 people actually came. Let's determine by what percent did Diego estimate incorrectly. So we need to determine the difference between the estimated value and then the actual value. So instead of determining how much did a number change by, we're determining how much are you off by your estimate. So my estimate was 75. It was actually 90. That's a difference of 15. Again, we want to keep the value positive. We're just looking at the difference between the new numbers. We'll be comparing the difference to the actual amount. So looking at this proportion right here, we have my percent that I'm trying to figure out. The actual amount, meaning the people that actually came, was 90, right? Before with percent change, it was like the original. We're figuring out the actual, which is very similar. And then here is my change, or my error amount. So my error was 15, my actual was 90. So I'm going to solve it the same way. I have my variable here in the numerator. I'm going to multiply each side by 100. So I have 15 times 100 divided by 90, and that is about 17%. Your school was having a contest to guess how many marbles were in the jar. You guessed there were 225 marbles, but there were actually 315 marbles. Let's determine your percent error, the difference in your estimate and the actual value. So I need to first determine how much I was off by. So the difference between 225 and 315 is 90. And I can do that by subtracting 315 minus 225. Again, I want to keep the number positive. I'm just looking at the difference between the two numbers. And then the actual amount was 315 marbles. So that goes here in my denominator of my proportion. Complete and solve the proportion. Okay, so I have my variable here in my numerator. I'm going to multiply each side by 100. So 90 times 100 divided by 315, and that's going to give me about 29%. Again, here is a summary of percent error, similar to percent change, but different. So the difference over the actual amount and then my percent ratio. Sandy received 110 votes in the primary election and 135 votes in the final election. Calculate the percent change. All right, so we're going from 110 to 135. And I'm calculating percent change. So I need to figure out how much did it change by and what was my original amount. So from 110 to 135, that changed by 25 votes. And the original amount was 110 votes. And I don't know my percent, that's what I'm trying to figure out. And then over 100. So multiplying here, I'm going to multiply each side by 100 to get 1x. So I have 25 times 100 divided by 110 is going to be about 23% increase. You want to determine if it's an increase or decrease. I'm going to write an up arrow to determine that it's an increase. Next question, it says the basketball team scored 75 points their first game and 60 points in their second game. Calculate the percent change. Okay, so again, percent change. I need to figure out my change over my original amount. My original amount was 75 points. That's what they scored first. My change is 75 to 60. What is the difference between 75 and 60? That is 15. I can just go 75 minus 60 to get 15. All right, solving for this, my variable is in the numerator. Multiply each side by 100. I get 15 times 100 divided by 75, and that is a 25%, and that is a decrease because I decreased in the amount of points between the first and the second game. The statistician estimates the population of a city to be 1,500. The actual population is 1,725. Calculate the percent error. All right, so again, my percent, I'm trying to figure it out. So my percent error is going to be my actual amount here on the bottom, and then the numerator, it's going to be how much was the error by. So going from 1,500 to 1,725, I can subtract that. 1,725 minus 1,500 gives me 225, and then the actual one, what it really was 1,725. So solving here for my variable, I'm going to multiply each side by 100. So I have 225 times 100 divided by 1,725. I get that it's about a 13% error. Last question. Justin estimated 24 people would come to his meeting, but only 14 people came. So let's mark that, 24 to 14. Calculate his percent error. All right, so figuring out percent again. Percent error, my actual people that came would be 14. My error, how much was the difference of the error there? So 24 to 14 would give me 10. All right, I'm going to multiply each side here by 100. So I get 100 times 10 divided by 14, and that is about a 71% error. Okay, everybody, that's it for today. Thank you.